Corporate Finance Practice Problem using Excel. Coefficient of Variation 3 Investment Alternatives. Get ready, it's time to take your chance with Corporate Finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, note that we are in the Practice tab as opposed to the Example tab. The Example tab, in essence, being the answer key. Information on the left-hand side, we're going to populate information into the blue area on the right-hand side. Similar analysis as we had in the past, this time, however, considering investment options, imagining we have 3 different investment options, and then we're going to imagine the kind of outcomes that we might expect to have from those different investment options and compare and contrast them, trying to use our statistical type of analysis. So this will be a similar scenario that we've seen in the prior presentations where we applied it to basically an advertising type of situations that might result in different results. We're not going to break it down into a list of numbers this time, but just use the standard calculation that's used for corporate finance generally with these types of calculations. So we'd have to figure out the investment. We're going to have investment 1, 2, and 3, and then try to think about, based on prior investment and different things with regards to the investment, what we believe the return will be, possibly based on prior performance and similar investments, and then judgments as to the economy going forward. And then we want to give our probabilities here to assign how likely we think that return would be, and then we will calculate our expected value from it. So we're going to say if it's not a good return for option 1, we're going to have 400 in terms of the return. Probability going to be 20%. If it does good, possibly average, we're going to say is 800 based on prior performance. We'll say that's going to be 20% likely, and very good is actually more highly likely, we're going to say is 60% likely. Now, before we calculate that, just note in the second one here, we have different returns. For the second option, we're going to estimate different returns, but we have the same probabilities here of the 20-20-60. So same probabilities for option 2, but with the 20-20-60. And then option 3, we have different returns once again. And this time we have a difference in terms of the probability. So I got the 750 here. We got the difference in the probability. So let's do our calculations in a similar fashion as we did before. We're expecting this one 400, 20% likelihood. So 400 times 20. Then we'll take the 800 times the 20% likelihood. And then the 1,350 times the 60% likelihood. Obviously, the likelihood needs to be adding up then to 100. That then gives us our expected value. The expected value totaling that 1,050, which you could basically think of the expected value as kind of like the average value, what we expect to happen. So that's, if you're thinking about a series of numbers, what we would think of kind of like the middle point or the average type of point, not the median, but the average, the middle type of point. And then we want to think about how much spread is going to be involved in that with regards to the data. And that spread then could be interpreted here as risk that would be involved. So if we're saying that we think then the average return 1,050, and then we can think about how much risk there's involved with regards to the spread of the data based on this. So let's do that here. We're going to say then the return, let's say this is going to be equal to the 400. We're going to bring that on down for the 3 results here. So bring that on down with the autofill. The expected value, basically the average, the 1,050. I'm going to just say this equals the one above it and the one above it. Then we'll subtract these 2 out, this being the 400 minus the 1,050, this being the 800 minus the 1,050, this being the 1,350 minus the 1,050. Then we're going to square it as we did in prior presentations. So we're going to take then this number, shift 6 or caret to the 2 power of 2 or squared. And then we'll copy that on down, copying that on down. Then we got the probabilities that we're going to apply here, the 20-20-60 in this case. 20. Let's make these 3 cells percentized by going to the number group and make it a percentage cell. 20, and then 20, and then 60. 20, 20, 60. That's what we got here. Then we'll take this equals the 422.5 times the 20%. This equals the 62.5 times the 20%. This equals the 90,000 times the 60%. Underlining here, underline, that's going to be the total. Summing that up, this equals the sum of these items and enter. We may also call that the variance, and then we want the standard deviation. So we'll calculate then the standard deviation And that's basically that we squared these items, so now we're going to basically square root it now. That would be the little symbol with a thing over the top of it. But in Excel, it would be equal to the square root formula or function of this item, 151. So that's the square root. Let's add some decimals to it. And we'll go to the numbers group, add a couple decimals. And then we want the expected value, which is kind of like the average. So that's going to be equal to then what we calculated, the 1050. And then let's underline that font group and underline it. And then we want the coefficient of variation. The coefficient of variation, which probably what we should call this top term here, since that's what we're the bottom line that we're kind of getting to here. Let's do that. And then let's divide this out. This is going to be this divided by that. Standard deviation divided by the expected value. Adding some decimals. You could represent this in a percent or decimals. We'll put 4 decimals there. Now this will make more sense, of course, when we compare this to other ones. So we can see what the average is that we expect to get from investment 1, 2, and 3 clearly. And then the next thing we want to do is basically look at the risk, which is often going to be useful to look at the coefficient of variation in that case. All right, so let's go to option 2. I'm going to say this is going to be equal to this. And this will be equal to this. Let's do it again. Why? Because it's good times. It's fun to do. Option 2, we got then this equals the 700 times the 20%. This is going to be the 1,400 times the 20%. And then the 2,050 times the 60%. Obviously, the percents should add up to 100 unless something went horribly, horribly wrong. Or maybe not that horrible, but something would go wrong if that wasn't 100%, you would think. Then if we sum this up, that would be the expected value. So obviously, looking at these two, the expected value here is higher than the expected value there. So it's like, I like option 2 then. Option 2 looks better. But then we want to think about, well, what's the risk that is going to be involved, for us to like not be at that kind of center point or average. That's where the coefficient of variation comes into play. So then we're going to say, let's do this calculation. Then we got the 700. Then I'm going to copy that down for the 3 options here. We're going to say the expected value is the average then that we just calculated. That 1,050 equals to 1,650, I should say, because that's the right thing to say. And I'm trying to say the right thing instead of the wrong thing. And so then we're going to say the average or the expected value is that 1,650. So there we have it. Oh, wait, hold on a second. The difference is what we're looking to here. That's what it says in the column title. The difference is going to be the 700 minus the 1,650, the 1,400 minus the 1,650, the 2,050 minus the 1,650, and then we're going to square it by taking that cell, shift 6 caret to 2, squaring it to the power of 2, the 2 power square power. So there we have that. And then we'll take the probabilities, the 20, 20, 60. I'm going to select these 3 cells first, make them percent format by going to the number group, percent format them. And then we'll pick up the 20 and then just simply autofill it. Let's do it with a copy and paste in this time. Copy it, down arrow, shift, down, control V, pasted. That 60 is obviously coming from there. Looks good. Then we'll multiply this out. We've got the 9025 times the 20. Let's do our copy and paste here. Control C, down arrow, shift holding down arrow, control V, pasted. It has been pasted. Pasted has been done. And then we're going to go to the font group and underline. This is going to be the variance. So the variance is going to be equal to the SUM shift 9 up arrow, holding shift up, and enter. Then we want the standard deviation, because that's like a squared number, and we want to take the square root of it, equals the square root of it. Square rooting it is going to give us that number of the 538 numbers group, adding a couple decimals to that. And then if I want to compare them to this data set up here, which had different numbers in it, right? This function of standard deviation took away that squared component. So now we're talking about actual dollar like units, but again, it's not as easy to compare like the spread or the variation from the deviation. And you'll note that these two basically had similar kind of probabilities here. So that's when the coefficient of variation comes into play. And we're gonna bring it into play right now. It's going to be brought right into play right here. So we want the mean then, the expected value, average or mean, and then underline that, font group and underline. And now finally, what we've been waiting for, the coefficient of variation being equal to this divided by this, and adding some decimals, number group, adding some decimals. So there we have it. So 3258 here versus the 3701. So we have notice we have the same weightings here, but obviously on different dollar amounts. So we have a different basically coefficient of variation. Now, if you want to analyze that a little bit more, just to see how that works out in a number series, you can do what we did in prior presentations and break these both out into basically 10 numbers, where you have the 400, 400, 800, 800, and then 6 of these, and then do your same kind of calculations, and you might get a better understanding of kind of what's happening, or picture this data set a little bit differently. Okay, let's do it one more time for the last one. This one we have the different probabilities here, so let's do this one. This is going to be equal to the 750 times the 40%. I'm going to copy it down this time, Control-C, down arrow, Shift, Control-V. Summing this up, this should obviously add up to the 100% again. The expected value, summing this up, gives us the 2,130. Now, the 2,130 is obviously higher than the other two, right? So everything else being equal, we would then, of course, like that one. But then we want to think about, what's the risk for that potential return that we might get, right? So we're going to say, all right, the risk, we're going to say the return, if we get the 750, copy that down, Control-C, down, Shift, down, Control-V, and then we'll take the expected value, which is kind of like the average that we just calculated right there, equals the one above it and the one above it. The difference, making the subtraction, the 750 minus the 2130, the 2550 minus the 2130, the 1050 minus the 2130. There we have that. Now we're going to square them. Equals this item, Shift 6, caret, to the power of 2, otherwise known as squaring it. Copying that, pasting it on down, Control-V. And then we squared all these two. Same thing, because these are hard-coded numbers, and they copied down with us. And then the probabilities, 40, 40, 20. Let's select these 3 cells and make them the percent type cell, number group percent type cell. And then we'll take the percent 40 and then copy that one down. Control-C, down, Shift, down arrow, Control-V. And then it picked up the relative cell references. And now we'll multiply it across. This equals this squared item times the 40%. Copying that down, Control-C, down arrow, Shift, down, Control-V. Make an underline, font group, and underline. And then this is going to be the variance. The variance being equal to the sum of Shift 9, up arrow, holding Shift, these 3 cells. Then we want to take the standard D. The standard D, and that's going to be equal to the standard hold on a second, square root equals the square root. Square root, that's how you do the standard D. There is a standard D formula, but we're taking the square root here. So in any case, we're going to take the expected value now so that we can get down to the coefficient of variation. So the standard value is going to, or the expected value, we calculated to be that 2,130. Underlining that, font group and underline, we then get the coefficient of variation. The coefficient of variation is this divided by that, standard deviation divided by the expected value. Number group, adding some decimals. So there we have it. Now, once again, if you look at this, at just this first calculation, you're going to say, well, this one, the expected value, what we expect to happen from these 3 investments, the higher number, the better, right? But then when you're looking at the coefficient, the larger this number, then the more risky it is. So when you're looking at the risk, you would say this one would be the least risky, right? It would be the least risky, and then this one would be second on the risk. So you want lower numbers here on the risk assessment. And then the most risky one would be down here. And that's kind of like what you would expect, obviously, because with the higher amounts here, or the higher possible gains, you would expect then the higher risk possibly to be aligned with that. So those are the two things that you're always trying to measure when you're projecting out into the future, the possible gains that might be there, and then the risk that's associated with those gains that you want to take into place. So for a book problem, then you'd be saying, or in practice, but the book problem will often be emphasizing the coefficient of variation to think about the risk. And they might ask something like, if you're a risk-averse person, which one would you pick? And you'd pick, the least risky one, which would be possibly this one. And notice this one has a higher expected return, and it's less risky than the second option, right? So the first option, even if you're more, you probably wouldn't be picking it because it's basically got, a lower return than the second option, and it's got more risk than the second option, right? And then so you'd probably be saying this would be the least, the one you'd pick if you're risk averse, and if you didn't mind risk and you're willing to take on risk in order to get a higher return, then you might be more inclined to pick the third one here. That would be the standard kind of process from basically the coefficient of variation, or the standard kind of set of questions you might get with relation to the results on it.